Hi everybody, this is Eugene O'Loughlin and welcome to my series of short how-to videos. In this video we're going to learn how to perform logical subsetting using a matrix in R. So before we start, let's create a simple matrix that we're going to use to figure out true and false values in our matrix. So first of all, in line 4 here, I'm creating a simple matrix which I'm calling table. Using the matrix function, I want a series of values from 1 to 12 in 4 rows, and by having those values 1 to 12 listed by row. So let me create the table first of all, print it out, and we can see we have a simple matrix here called table with 3 columns and 4 rows. And we can see then that our values are listed left to right, 1, 2, 3 in the first row, 4, 5 and 6 in the second row, and so on. So this is just about the simplest matrix that you can have. So we're going to use this to illustrate how we can check these values in these tables if they're true or false compared to a certain criteria. So to start, let's check and see, well, what values in my table here, or my matrix called table, are greater than 5. So if I just type out table greater than 5, so this should tell me which values in the matrix. So let's run this. And in my output here, you can see what the line 7 in the code has done. It is checking my matrix for all individual values greater than 5. So if a value is greater than 5, it will return a true value. If the value is not greater than 5, it will return a false value. And you can see that in the highlighted output in the console here. You can see that in row 1, the values 1, 2, and 3 are obviously not greater than 5, so they return a value of false. In row 2, 4 and 5 are not greater than 5, so they're returning values of false. But in row 2, column 3, the value of 6 is greater than 5, and all values in rows 3 and 4 are greater than 5, and they will return true logical values. So this is a simple way to determine if you wanted to check against a particular value in an entire matrix. But let's go now and look at and see by individual columns and individual rows. So let's, for our first example here, let's check column 2 for all values greater than 5. So we can see our column 2 here, all values greater than 5. We can see the values are 2, 5, 8, and 11. So let's check and see what we get here. So table, square brackets, remember rows first and columns second. So I'm going to leave the row value blank because we're going to check for columns in this case here. We're checking column 2. So that piece of code there allows me to display column 2 on its own, but I just want to then put in greater than 5. So look at the difference between line 7 and line 9. In line 7 I'm checking all values greater than 5. In line 9 I'm just checking the values in column 2 that are greater than line 5. So let's run this. And we can see in column 2, let me just extend the console here. We can see in column 2 we have 2, 5, 8, and 9. They're the values. And when we check this, we get a display of false, false, true, and true, because the values of 2 and 5 are obviously not greater than 5, while the values of 8 and 11 are greater than 5. So just be careful here the way R displays the output. These are column values. They're being displayed in a single line in this case here. So be very, very careful that you understand the difference between the outputs. Supposing now I wanted to check row 3 for values greater than or equal to 8. So row 3, all right, we have values of 7, 8, and 9. So this time I'm going to table, square brackets. Remember rows first, column second. So in this case here, I'm just checking row 3 column. I'm going to leave the 3 for the row. I'm going to leave the column value blank. And in this case here, I'm going to go use the operator greater than or equal to a value of 8. So run this. We can see we're getting false, true, and true. So if I scroll back up to my table here, so in row number 3, which is the values 7, 8, or 9, so 7 is not greater than or equal to 8, so that gives us a false value. 8 is equal to 8, and 9 is greater than 8, so we should get 2 trues, and that's precisely what we get with our output here. We get false, true, and true. Suppose we want to combine multiple columns. So let's go here now and try, let's say we want to check columns 2 and 3 for values greater than 5. So table, square brackets. Again, I'm not checking anything in rows here. Let me just get rid of that space here. So I'm going to leave a space blank and a comma. So no value for rows in this case here. And 2 using the colon to 3. So all columns 2 to 3, I'm going to check these for values greater than 5. So when I run this, You can see columns 2 and 3 have been displayed. Just be careful, OR displays these as columns 1 and 2, but we're actually showing columns 2 and 3. But in this logical subscripting, we are taking out, creating a new matrix here, and we can see values greater than 5, false, false, true, true, and false, true, true, true. So you can compare that to the table. What about, we want to check rows at this time here. So let's check rows. I want to check rows 1 and 3 for values less than 5. So again, I'm going to use 1 and the colon and 3. So rows 1 to 3. Remember, our data set has 4 rows in it, so we're subsetting here, comma. I'm going to leave the column value blank, and then I'm checking for values less than 5. So let me run this here. And again, we can see here in the rows, we've got rows 1, 2, and 3 being listed here, and what values are less than 5. So 1, 2, 3, and 4, they're all less than 5. And then the middle value here of false, that's the value of 5 in our matrix, so that's not less than 5. So that'll return a logical value of false, and as the other values are being returned false there. So experiment with the simple matrices like this until you get handy at putting information, selecting information on a true and false basis from your table. Now let's take a quick look at a real sample data file. So I have on my clipboard here, so let me just paste in some code, information here. I have on my clipboard data taken from the NBA, National Basketball Association's website. And these are values that are contained in a file which I have in my working folder here. And this file, along with all files and scripts for this series of videos, is available in my GitHub. You'll find a link to that in the information section below the video on the YouTube page. So we can see here I'm reading a CSV file called 51_data_file.csv and various parameters there to display this file. And I'm going to store the contents of this file in a vector in a matrix called sal nbna. So let me run this first of all, and then print out the values so that we can see what we have got in the output. So we can got data from 2008 to 2014. We can see the salaries for some well-known basketball players in the left-hand side here. So we've got our column names and row names, and so we can now say, for example, we want to check for values greater than say 15. These are all millions of dollars. So I'm going to check 2009. So that's the second column here. So I'm going to check 2009 for values greater than 15. So who earned more than $15 million in 2009? So let's go ahead and write the code for that. So sal NBA, this is the name of my matrix. Use the square bracket. So I'm not checking any rows, I'm checking columns in this case. I'm checking the column for 2009. I can refer to this by number, but I'm going to refer in this case here by name, 2009. So this needs to be in inverted commas. So 2009 and square brackets, and then greater than, I'm checking for greater than, say, $15 million. 15123, that's $15 million. So now let's run that piece of code. So in 2009, we can see that the first row was true. That player earned more than $15 million. The second player didn't earn more than $15 million. The third player did, and so on. Not terribly useful on its own because you're missing out on the row name in this case here. What about if we want to check for salaries in the years for that LeBron James, for example, earned more than $15? So again, sal NBA, square brackets. This time LeBron James is in a row, so I'm going to put him in by names. LeBron James, and I'm going to leave a comma. Then I'm going to leave the, sorry, I put the comma after LeBron's name, and leave the column blank. And in this case here, I'm going to again check for $15 million, so greater than $15 million. So when I run this piece of code, we can see a little bit more interesting output here, that James didn't earn more than $15 million in 2008, but did so in 2009, didn't in 2010, and did earn more than 15 for 2011, 12, 13, and 14. So you can see, this is a very small matrix here, but you can see how you can access values in columns and in rows, and this might be useful for you to do some simple data analysis. So if you're looking for, stock levels or high salaries greater than a certain value, using true and false in this way will help you analyze your data. So that's how you perform logical subsetting in R. I hope you found this video useful. Thank you for your attention.